Hello everyone. Today we are going to solve a few questions from CBSE 9 standard textbook. Okay, the lesson is going to be polynomials. We have done a bit of videos on polynomials as to what it is, just the basics. Please do check it out. It's going to be of great help. I will link it down in the description below, right? Let's get started with exercise 2.1. The very first question, which of the following expressions are polynomials in one variable? Okay, it has to be a polynomial and the polynomial should have only one variable used. And which are not, state your reasons for it. Okay. So two things that you're going to look for here, if it is a polynomial or not. How do we know if it is a polynomial or not? We are going to look at the powers of the variable in that expression. Okay, the way we are going to look at the variable, we are going to look at the power, and we're going to see if the power is a whole number. If it is a whole number, that expression becomes a polynomial. Okay, the second condition is it has to have only one variable. Now, how do we identify this? Only one type of alphabet is supposed to be used in that polynomial for it to become a polynomial in one variable. Okay, alphabet, only one type of alphabet. So your first question for x squared minus 3x plus 7. Here, if we look at the variable and their powers, we see that one has 2 and other one has nothing, which means that it is 1. All right. So both 2 and 1 are whole numbers. So yes, this expression is a polynomial. Now, does it have only one variable? Yes, both of them have x used. I'm sorry, x is used in throughout the polynomial, which is only one type of alphabet. So this is a polynomial in one variable. For the next question, y square plus root 2. Y is the variable. We have square, which is 2, that is a whole number. So yes, it is a polynomial. Does it have only one variable? Yes. Only y is used throughout the polynomial. So yeah. The next question is, okay, let's do this one, right? 3 root t plus t root 2. That can be a tongue twister. Okay, so I can write this expression as 3t to the power of half plus t root 2. Here we have half, which is not our whole number, so this expression is not a polynomial. Okay, so this is gone. Yep. Now, how did we get root t as t to the power of 1 by 2? Whenever I have an expression or a number or an alphabet or whatever under square root, I can write it as t to the power of 1 by 2. All right. So basically, your square root is nothing but the reciprocal of your square. Okay. So let's say I have maybe 2. So root 2 can be written as 2 to the power of half. Okay. Let's say I have root 7a. Okay, I can write this as 7a to the power of half, or 1 by 2. Okay, so with that respect, that is not a polynomial. Now, the next question is y plus 2 by y. I can write this as y plus 2y to the power of -1. -1 is not a whole number, so this expression is not a polynomial. Okay. Now, how did I get -1 here? How did my 2 by y become 2y -1? When I have something in my denominator, I want to bring it up to the numerator. And when this thing goes up, the power of this expression or variable or whatever it is will become negative. Okay. Here I know when there's nothing, it means that there is power 1. So when that goes to the numerator, it gets a negative sign. It changes its sign. Okay. Let's take another example, maybe 1 by 2a to the power of 5. Now, when I want to bring this up from the denominator to the numerator, I can write this as 2a to the power of -5, right? So, according to that concept, yes, this is -1 and it's not a polynomial because -1 is not a whole number. So, this is gone. Now, for the last question, x to the power of 10 plus y cubed plus t to the power of 50. Now, over here, we can see that we have all of the powers to be in whole numbers. So, yes, it is a polynomial, but is it in one variable? No. We have three different alphabets used over here, which is y, x, and t. And that is not a polynomial in one variable. All right. So moving on to the second question, we have write the coefficients of x squared in each of the following. Now, what are coefficients? It is a number which is along with a variable. Okay, or a coefficient is a number which multiplies the variable. Okay, let's say I have 2 to the power of x squared. The coefficient of x squared becomes 2. I have 34xy. The coefficient of xy is 34. Let's say I have another example, uh, 3y cube. The coefficient of y cube becomes 3. Okay, so a number which is next to a variable, like it is in multiplication with that variable, that is your coefficient. Here we have 2 plus x squared plus x. Here we are supposed to find out the coefficient of x squared. This is my x squared. What is the number along with the x squared or in multiplication with x squared? There's nothing. When there's nothing, it means that there's a 1 there. You just don't write it because anything multiplied with 1 becomes the expression itself, right? So, yeah, so the coefficient of this is 1. Now take another example, my 2 minus x square plus x cube. Your first one, this is the second one. So we have an x square here and we have a negative sign over here. Now when I said when there's nothing, it means that there's 1. Yes, so it will be 1. But what about the sign over here? It carries the sign along with it, okay? So the coefficient of x square is negative 1. All right. Looking at the third question, pi by 2x squared plus x square's coefficient is pi by 2, as simple as that, okay? Fourth question is root 2x minus 1. All right, for this question, we do not have an x square, okay? That means that we can write this expression as, okay, when there is no expression of that sort, like for example they've asked you for x square here, but then we don't have x square, it means that it was multiplied with a 0. When you multiply with anything with 0, what happens? The entire expression becomes 0, right? So this expression is equal to this expression. It's just that this is not written, but we can write it because it means the same thing, right? So what is the coefficient of x squared in this expression or this polynomial? It is 0. Okay, I hope so far it is clear. Let's move on to the third question. Give one example each of a binomial of degree 35 and a monomial of a degree 100. Okay, so what do you mean by a binomial? A polynomial that has two terms in it. Like for example, 2x squared plus x becomes a binomial. Okay, so an expression, they have two terms, they become a binomial. All right, so now we need a binomial with the degree of 35. When I talk about degree, it means that the highest power a polynomial can have. So the highest power in this question is 2. All right, so how can I write a example for binomial of degree 35? I can just write any binomial. Let's say I'll write 2x plus 4. Okay, but I need the highest degree to be 35, so I'm just going to put a 35 here. So I have a binomial, it has two terms, and the highest degree over here is 35. I can also write another expression like 3x um, to the power of 35 plus 4x. That is a binomial. Okay. Now the next one is a monomial of a degree 100. Monomial is one single polynomial or one single term in an expression. So 2x is a monomial, right? Now, when I say monomial with the degree of 100, the highest degree of that polynomial expression has to be 100. So I can just write 2x to the power of 100, and this becomes my monomial with the degree 100. Okay. Taking another example, 4x to the power of 100, or just x to the power of 100 will also work. Okay. Okay. Moving on to the fourth question. Write the degree of each of the following polynomials. All right, so we are supposed to write the degree. When we talk about degree with respect to polynomials, it always means the highest power is degree. Okay. Um, 5x cubed plus 4x squared plus 7x, which is the highest degree over here. What are the different powers used in the first question? There is 3 here, there is 2 here, and there is 1. Okay, so 3 becomes the highest. So For the first question, the degree of that polynomial is 3. Okay. Next is 4 minus y square. We have 2 over here, which is highest, right? So 2 becomes our degree of polynomial for that one. So we have 5t minus root 7. Here, when there is nothing in the power, it means that there's 1. And is there any other variable with any other power here? No, that is the only one. So the highest power over here is 1. Now we have a 3. What is the degree of a polynomial which is non-zero, okay, or the constant polynomials? This is called as a constant polynomial in the sense like this doesn't really have any other terms along with it. It's just a number and we call it as a constant polynomial. The reason is we can write a constant polynomial in the sense 3 as 3x to the power of 0. I can express this 3 in an expression, like I can convert that into an expression. This became an expression, hence it is a polynomial, all right? It has a variable, it has power in it, and it also has a constant along with it. Okay, so this becomes a nice, a good little expression, and we can call it as a polynomial. Now, does this have a degree? Yes, it does. What is the degree along with it? 0. Now, you might ask, how is 3 and 3x to the power of 0 the same thing? The reason is anything raised to the power of 0 becomes 1. So if I have 2 to the power of 0, it is 1. If I have a huge number, say 270017 to the power of 0, it becomes 1. So hence, when I write this, it is the same thing as 3 into 1, which is nothing but 3. I got this back, right? So I can express my 3 as 3 to the power of x, 3x to the power of 0. All right. So it's just about manipulation here and there, just playing around with your expressions and numbers. All right. 3x0 can be written as 3, or 3 can be written as 3x to the power of 0. Hence, the degree of this polynomial will become 0. So in general, you can remember a constant polynomial, which is also called as a non-zero polynomial, has always degree as 0. Okay, this is let's just consider this as a fact or something. This is always constant. Okay, this can never change. So just remember this. So you see a number anywhere and they are asking you for the degree of it, it is 0 all the time. Okay, all right. So we have the last main left, fifth one. Classify the following as linear, quadratic, and cubic polynomials. Now, linear polynomial is when the power, the highest power or the degree of the polynomial is 1. That is your linear. If the degree of the polynomial, let's just write DOP for degree of polynomial. If the degree of polynomial is 2, it becomes a quadratic. And if it is 3, it becomes cubic. Okay, so for the first one here, x squared plus x. Here, x squared plus x, the highest power over here is 2. So the first one is quadratic. Okay, x minus x cube. The highest power over here, or the degree of polynomial, is 3. So this becomes cubic. Y plus y squared plus 4. The highest power over here is 2, which is quadratic. 1 plus x. The highest power over here is 1. This makes it linear. Okay. 3 times t. The highest power over here is 1. So this is linear. R square, 2 is the highest power, makes it quadratic. 7x cube. Cube is 3 is the highest power, so it becomes cubic. So that is it for exercise 2.1. I hope everything was clear. If you do have any doubts, please do comment. I will try my best to answer and clarify all your doubts. Okay. And I will be posting the next exercise and further exercises. So stay tuned and thank you so much for watching.